Well, good afternoon. If you've wandered on by to hear about U.S. National Grid emergency location markers, reducing response times and saving lives at the WLIA annual conference of February 18th, 2001, you are in the right place. I'm Steve Swayze, and I'll be walking you through the story. To start off, I need to frame the discussion by telling you about the nonprofit Shared Geo, where I serve as executive director. Three key points about this organization, which was founded in 2008 and serves as the public domain guardian of the emergency location marker, or ELM, concept. First, we are a geospatial research and development nonprofit. Second, we develop geolocation technologies with the intent of placing them into the public domain so they may be freely used by others. And three, our project work ranges from the very simple to some which are cutting-edge complex, involving big data and supercomputers. Bottom line, I want to drive home the point: we are a geospatial research and development nonprofit, not an entity which was originally set up to work on a daily basis in the sign or trail development world. Indeed, we came at the issue of standardizing emergency response trail markings from a geospatial perspective of helping the emergency response community. That being said, we became part of that world in 2009 when we were approached by B.J. Kolstead, an emergency manager in Lake County, Minnesota, who brought us the problem statement you see on the screen. She said, "Steve, we're getting calls into the 911 center that go like this: I'm lost between Ely and the Canadian border. Come get me." That request equals a search of about 60 miles of trail in an area where the bugs will kill you in summer and minus 35 to 45 below zero will kill you in winter. Indeed, taken together, the three counties which make up the Minnesota Arrowhead are larger than 9 states, and outside of the Duluth metro have a population of about 25,000 people. Getting lost in this wilderness can turn deadly really quick. Related to this kind of situation are accident locations. Accidents have this bad habit of repeating in the same spot, but the injured can't effectively tell you where that location is. Then there is the lack of specificity. I'm hurt at Gooseberry Falls. Gooseberry Falls is a very scenic park in northern Minnesota, but if responders come down the wrong side of the river that leads to Gooseberry Falls, it will be another 45 minutes before they'll be on the right side of Gooseberry Falls to help you. And as I've already mentioned, the sheer size of the search and rescue areas with limited volunteer assets to respond means anything which can be done to help trail users identify an accident location will go a long way towards speeding a response and potentially saving lives. These circumstances tell us there's an underlying national problem when incidents don't happen at a street address. Data from Delta State University indicates roughly 34% of response calls in the U.S. go to a location without a street address. Recreational trails are a leading category. Trail systems and parks typically employ a marking approach which is locally unique. But locally unique marking systems have no value to responders unless those locations are readily available in dispatch and response system. That involves building and maintaining a GIS layer in every fire, EMS, police, private ambulance company, dispatch, or whatever system that could be out there responding to a call on a trail system. After pondering this situation, Shared Geo decided to come at the situation with 5 design objectives. First, develop a standardized emergency location marker, ELM, which can be used anywhere in the nation in a variety of scenarios. Second, align the marking system with established federal and state cartographic and signage standards. Third, Ensure the format leverages GPS instead of requiring constant updating of computer-aided dispatch systems. 4. Use a consistent approach which over time will become instantly recognizable by the public. A standard, think stop sign. Everybody sees a stop sign and understands what it means. And involve multiple stakeholders during development to ensure a best practices outcome. Consequently, to develop the signage you'll see shortly, over the course of 3 years we worked with a variety of concerned parties and stakeholders, which included Minnesota Geospatial Advisory Council's Emergency Preparedness Committee, Minnesota Department of Transportation, Minnesota Department of Natural Resources, 5 visits to the Lake County, Minnesota focus group, which included law, trail riders, search and rescue, fire, tribal, and federal partners. And reviewing our work throughout was a national focus group of responders and geospatial experts. Through this process, we collectively arrived at the belief that the way forward for an emergency location marker system was to use the U.S. National Grid Coordinate Standard. U.S. National Grid, or USNG, is nothing more than the U.S. portion of the Military Grid Reference System, MGRS, a well-established worldwide metric coordinate standard used by NATO and the U.S. Armed Forces since the late 1940s. And its adoption for U.S. emergency response has been steadily growing over the last decade. In November 2011, the 7 federal agencies which comprise the National Search and Rescue Committee designated USNG as the standard for all ground-based search and rescue operations in the U.S. In October 2015, FEMA designated U.S. National Grid as its primary coordinate system and encouraged all other partner organizations to do the same. USNG effectively became the nation's emergency response language of location. As of today, there are now multiple organizations and government entities who have endorsed its use. Here are some of them. One recent notable was the 127,000 members of the Society of Automotive Engineers International, who issued a U.S. National Grid engineering design standard in late 2018. However, regrettably, past experience would suggest few trail users or emergency responders realize U.S. National Grid is already part of their world through at least 2 of the more popular navigation products found in the community. First is the free-to-download USGS US Topo Map series, which in its current and previous form has been published by the U.S. government for over 130 years. If you look carefully, you'll see USNG gridding and location information hiding in plain sight on this nationally standardized product. Same thing with GPS. Pretty much any GPS unit manufactured since about 2008 will have the ability to select USNG or Military Grid Reference System over the default factory setting of latitude-longitude. Similarly, with release of the 2019 Federal Radio Navigation Plan, federal money spent on aviation navigation systems must consider the need for a USNG capability in that type of equipment, a SAR helicopter as an example. Speaking of navigation, right about now there's a lot of head scratching with people asking, what's wrong with using latitude-longitude? The bottom line is latitude-longitude was invented for global navigation, not for emergency response in a localized area. Here are some of the issues. First, it's base 60 math, using non-standardized trapezoids, which are not conducive to responders' understanding of local location relationships. This complexity is the reason aviators and sailors spend scores of hours in specialized navigation training programs. Second, it will take up to 13 digits of latitude and longitude to get the same level of specificity you can get with just 8 digits of a U.S. National Grid coordinate. And finally, the worst thing of all about latitude and longitude is there are 3 versions. Confusion about which version was being used to relay information about an incident location has sent responders to the wrong location with deadly results. Effectively, the world is flat when it comes to local location. On the one hand, you can use the base 60 math and the trapezoids of latitude-longitude, or on the other, you can use base 10 math and the uniform-sized squares of the U.S. National Grid. When considered by the collaborative group I previously described, this one was a no-brainer. And that is how U.S. National Grid came to be the coordinate system displayed on the emergency location marker that came out of a developmental process which looked something like this. Which brings us to the end product. The U.S. National Grid Emergency Location Marker, or ELM for short, has the following elements. For the 911 emergency identification, the Star of Life symbol was used to avoid a proprietary issue associated with using the Red Cross. Next comes 2 items which begin narrowing down the location of the ELM. However, because they have value only in extremely rare circumstances, they are displayed using smaller font and set off from the box with 8 digits. First is 15T, the UTM grid zone, a notation for an area which is 6 degrees longitude wide by 8 degrees latitude tall, an area that is the size sufficiently large enough to cover almost all of Minnesota and Iowa. Consequently, in reporting a location, it applies only to people who are in Minnesota but actually think they're in Michigan. Second is what is known as the 100-kilometer grid square identifier, in our example denoted by WM. Each UTM grid zone contains approximately 45 squares which are 100 kilometers on each side. The notation WM lets us know which of these 100-kilometer grid squares is being referenced with 8 big digits below. Since a square is 62 by 62 miles, is another large area, in all but very rarest circumstances, we are now down to only needing to report the 8 digits in the white box. Those 8 digits of a USNG coordinate, 2 numbers less than a full phone number, when called into a 911 center, provide 33 feet locational accuracy within an area covering 3,861 square miles. Few call centers cover areas that large, and if responders can't find somebody within 33 feet, well, then there's other big problems. The final design element of the ELM include use of Federal Highway Administration color and font standards, repairability features, and use of an approach which can be maintained in the public domain. Now let's visually pull it all together. On this slide, you'll see the relationships of alphanumerics to area. As I've mentioned in the Minnesota example, 15T covers a very large area. In this example, Victor Kilo represents one of the 45 some 100-kilometer grid squares in 15T, and the 8 digits tell us about a location within that 100-kilometer square. And because you are working with base 10 math, those scary-looking digits are nothing more than a percentage of movement from the lower left-hand corner of the Victor Kilo grid square. The first number moves us right or east, approximately 90% of the way across the square, and then the second number moves us up or north, about 60% of the way in the square. Basically, all you have to remember is read right, then up, just like in grade school when working with X and Y axes in units. 9 units right, 6 units up. So, by what I know about basic Minnesota and Wisconsin geography, and with nothing more than a simple graphic, I just figured out a response is needed on the east side of the Twin Cities suburbs, a process which, when repeated on an appropriately scaled and visually detailed map, will show a location with 10 meter or 33 feet accuracy. When we finally released our first ELMs in 2012, we offered 3 sizes to our pilot partners. 12 by 12, the size the Minnesota DNR endorsed for use at trailheads and warming huts. 9 by 12, the Minnesota Department of Transportation standard for motorized trails used by snowmobiles, ATVs, and similar. And 6 by 9 as recommended by our focus groups for use on hiking, cross-country skiing, jogging, and other human-powered type trails. Driven by a reduction in trail response times that have been reported as high as 90%, this first project in northern Minnesota has now become multi-state deployments and inquiries. 2 of the more interesting are: in 2018, a select panel working for NASA's chief technologist, the Science Office of NASA, selected ELMs for installation on Kennedy Space Center. That system is now supporting over 1 million visitors per year at this nationally unique site. Similarly, in 2020, headquarters of the National Park Service authorized installation of ELMs on Kennesaw Mountain National Battlefield Park, a park which sees over 2.5 million visitors each year. In addition to the expanding number of locations where you will find ELMs, we've also worked with our trail partners to continue developing different versions which support different use scenarios. There is now a vertical breakaway version, a 3x5 sticker which can be used to retrofit fiberglass posts, and customized versions to support specific local needs. To support awareness, we have also developed a standardized information sign which is available either in metal for posting or polyvinyl to support responder training events. Another issue that has been addressed is the creation of the informational kiosk. In this case, the product has been engineered so that it can be attached to a wooden backboard or attached to post with pre-drilled holes, U-channel or other. It is also printed on both sides, so there is the opportunity to rotate to a new sign if only one side had previously been visible. In response to requests for supporting items, we have developed trail access point signage for responders and unique items like call box informational placards. Finally, as I indicated when we began, we are a geospatial research and development nonprofit, so we have also been adding to the technologies available to support USNG implementation in general, and ELMs specifically. Here are 2 examples. First, usngapp.org. Simply entering that URL in any mobile platform instantly displays your USNG location in the format of an ELM. And once loaded in your browser, it no longer needs an internet connection. We are aware of at least one significant rescue which has been facilitated by this technology. Second, for those who would like to print an ELM on demand, we've created a point-and-click print map interface which also has a derivative which will allow mountain bike racers or whoever to go into the field and print race course markers on demand on site. As I approach the end of this presentation, the question I get most often is, okay, this is all well and good, but it looks way too complicated, and how would I ever undertake a project like this? Basically, There are 8 steps which any determined individual should be able to make happen. First step is the most important, and regrettably, there isn't much point in proceeding past step 1 if you can't make it happen. With ELMS, you are installing a community product, not just something for your trail system. So you need to build a team that believes in the collaborative process and understands effort up front will ultimately benefit the community by reducing response times and making the public feel the trail is safe. So you'll need all these stakeholders at the table, all willing to recognize trail response could be handled better than it has been. Then it's, here's this idea, what do you think? If you can come out of that first step with a green light to continue planning, your next step is to create a rough plan for your trail system so you can get a handle on potential cost. To that end, here are some of the basic planning factors which you can use to create a rough estimate of what it will cost to place ELMs on your trail. If you are planning a rural trail system, anticipate you'll need 1 ELM per mile to meet location needs I'll explain in a minute. Whereas on an urban trail system, ELMs average about 1 every quarter mile. Budgeting factors for delivered, tax-paid items are currently approximately $30 for an ELM, $35 for an info sign, and $55 for a vertical ELM. We expect those costs to come down over time as we gain efficiency in production, planning, and management. Hardware has historically run roughly 10% of the total cost of the signage in the project. Depending on how your team is approaching your ELM project, the next 3 steps can be happening simultaneously or pretty much in any sequence. First, you'll need funding. There are a variety of places to look for funding. To name a few, federal and state trail safety improvement programs, corporate safety grants, trail user fundraisers, local government funding, and even sweat equity. Labor donated by scouts, trail riders, hunting organizations, etc. Next, you'll need to accurately record the location for your ELMs. Although each community is different, those locations have typically been trailheads, road crossings, known accident locations, trail junctions, camping areas or rest stops, and set distance if you're working with an urban trail system. Last, you'll need to order your ELMs, info signs, and hardware. Beforehand, you'll need to work through lots of issues with your team, some of which include contract, purchase order, credit. How should we do this? ELM sizes, mix and type. Custom products. Where are the supporting artwork and logos that we'll need for our ELMs? Engineer or high-intensity prismatic laminate. 3M or Avery laminate. Type of post. What hardware will be needed? Is our ELM location spreadsheet ready to go in the format requested by the manufacturer? Obviously, many of these questions will have been worked out in advance during talks with ShareGeo if a self-installed project, or with a certified ELM installer if the job has been contracted out. But at this point in the project lifecycle, a final review is in order given the unique nature of this approach. At step 6, there are 2 basic needs. For first responders, train, train, train. Because once ELMs go up, the first call could come moments later, and for call centers, depending on CAD configuration, ensure both the operators and equipment are ready to go. Step 7 is straightforward. Install ELMs and keep practicing. Finally, at step 8, you'll need to publicize your efforts to ensure the public knows how to use the ELM system. Examples of past efforts include YouTube videos, stories on local television stations, informational brochures for public outreach, and blogs, as was done at Kennedy Space Center. Then there are story maps, hands-on displays at safety training centers, and even festivals. Well, this all looks like a lot of work, and would we really get any kind of return on investment out of all this effort? Consider the cost of a SAR helo if someone is lost on your trail system, and it comes down to needing to use infrared to find them. The tab is going to run at the rate of $5,000 to $8,000 an hour. Then there is the question of what is a life worth. In May 2013, school children from an outlying suburb of the Twin Cities were on a field trip to Lilydale Regional Park, which is situated in the very metro setting of St. Paul, Minnesota. 2 children from that group got buried in a landslide, and it took responders nearly 50 minutes, as in 50 minutes, to get to the site because no one could adequately describe where the incident had taken place. So after the tragic deaths of these 2 children, and a payout of $1.5 million in claims and engineering studies, what was one of the steps the city took to correct the situation so it was protected from another tragedy of this nature? They spent $736 to install ELMs in this park. I believe the return on investment with this one is pretty obvious. As I said in the beginning, ShareGeo never intended to get in the sign business, but here we are. To that end, we are currently in the process of substantially upgrading our online store with ELM system planning information, ELM stories in the press, videos, and similar. If you are interested in learning more about the ELM system, stop by and check it out. Thank you. That concludes this presentation. Please feel free to contact me at the email shown on the screen if you have questions or you would like to discuss an ELM project in your community. Thank you very much.